My dear students, today we'll discuss about the determination of top and bottom of beds of deformed strata by use of the primary features. We know that the strata in some places are not found to be in right side of condition because of deformation. So how can we establish whether the strata is in right side or the strata are in right side of condition or are totally overturned? So to establish it, we take into account several features on the basis of which we can prove that the strata are in right side of condition or are overturned. That is, whether they are facing upwards or the strata are facing downwards. If they are facing downwards, that is a case of overturning of beds. So let us discuss in a systematic way how we can establish the right side of condition or overturning of the beds in field. First point is the attitude of bed. By taking into account the attitude of bed, it is possible to find out the measure structure, and on the basis of the measure structure, we will be able to say the right side up or overturning of the beds. So in different areas, strata are found to be folded. Where folds are clearly visible, it is possible to identify whether the strata in them are in right side up condition or are overturned. But due to erosion, on many occasions, the true picture of the folding is not seen on ground. There, we take into account the deep and strike data available in different outcrops, and we try to correlate them in order to deduce the eroded structure. Let us say this is a folded bed. If erosion takes place so that these top portions are found to be removed, these top portions are found to be removed. So we are having these beds that show their dips. So these deep data are available in the field in different localities. So we try to take into account these deep values, deep directions, and try to correlate these data. And on that basis, we can deduce the measure structure. So this will be the structure, 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 this will be the, so which was eroded. So deep and strike data, they are taken into account and are correlated to see whether a limb is right side up or is overturned. Here it is a case of compression. If the compression will be more, it will gradually become vertical. If the compression will be further more, it may get overturned. So here the bed has been overturned. So this fact we can determine if we correlate the deep values and try to deduce the measure structure. So this picture is useful to say how the deep of beds are useful to deduce the measure structure. So at A we see, at A and B we see that beds are dipping towards east. They are dipping towards east, this side. And at C the bed is dipping towards west, towards this side. So the possible correlation of strata establishes the fact that it is one anticline. This is an anticline in which the eastern limb gradually becomes vertical and got overturned at C. This change in deep angle of the bed in one area of survey can establish the up-facing or down-facing of beds. So here the strata has been overturned. So this is top, this is bottom. Therefore, by taking into account the deep and strike values of beds, eroded beds, it is possible to deduce the major structure. Similarly, by taking use of the fossils through a paleontological method, it is possible to say the direction in which the beds are young and the direction in which the beds are older. The normal process is that the younger beds are found always in the deep direction of beds. If along the deep direction of beds fossils of older age are found, it is a clear case of overturning of beds. So if you look at this diagram, the beds are dipping towards west. So if you move towards west, we will see that the beds occurring towards west must be younger in age. But here the fossils that we trace that are older fossils. But the fact is that at the time of formation of a bed, the organisms living at that time are found to be trapped in the sedimentary beds and are found to be fossilized. So the age of the fossils is equal to the age of the stratum which contains it. Therefore, if we find older fossils at this site, and younger fossils at this site, it indicates that there has been a reversal of beds. This is youngest side. This is older side. But on the younger side, we find older fossils. That's why the strata is overturned, and that has been established by the availability of fossils. Next, the ripple marks. How ripple marks are useful in determination of top and bottom of beds. We generally find two types of ripples. One is oscillation ripple, the other is current ripples. The oscillation ripples are symmetrical ripples which present sharp crest and broad top. Top is broad, crest is sharp, and it is symmetrical ripple. If you take into its cast, it will be of this type. The crest will be pointing towards top. But in any horizon, in a rock bed, we find that this is showing this type of structure. That means this sharp end is pointing downwards. It is a clear case of overturning of beds. Because as per its very formation, these crests, they always point towards the top. It cannot be towards the bottom. So here it has been deflected toward the bottom. That's why the cast, which is showing these crests pointing downwards, and the bed which contains this type of cast, this type of ripple marks, is totally overturned. So these symmetrical ripples or oscillation ripples are useful in tracing the top and bottom of beds which contain them. So these sharp crests must have to be studied. But in case of asymmetrical ripples or current ripples, we see that the cast and the original ripple, they look the same. Therefore, it is of no use in determining some top and bottom of beds. Only oscillation ripples or symmetrical ripples are useful in determining top and bottom of beds. Next, we will switch over to cross-bedding or cross-lamination. How it is useful in determining top and bottom of beds. If you analyze any crust bedding in field, which are mostly found in deltaic environment, they present three types of beds: foreset, topset, and bottom set beds. The topset and bottom set beds are nearly horizontal, and the middle set bed, which is called foreset bed, it is found to have a truncated end towards the top and is found to have a tangential end at the bottom with the bottom beds. So, truncation to the top, tangential ending to the bottom. This fact is taken into account. So, tangential portion is the bottom side. The truncated side of foreset beds is the top side. This feature is observed in field to identify which side of a bed is top, which side of the bed is pointing to the bottom. So this side we see how it is occurring in a rock bed, and on the basis of which we can establish that the concerned bed is in right side up condition or in overturned condition. If we see it in this manner, so this should have been this is the bottom side, but it is now occurring on the top. So here it has been overturned. So in this way, the crust bedding is useful to determine top and bottom of beds. Then graded bedding. How graded bedding is useful in determining top and bottom of beds? In graded bedding, there is a gradation of grains. There is a fining upward sequence of sediments. So this is fining upward sequence. In normal case of deposition, we see that the beds are having fining upward sequence. Fining upward particle. This is the normal sequence of sedimentation. Hence, finer particles occur to the top and coarser particles occur to the bottom. This fining upward sequence, which we generally find in turbidity currents that has been stabilized, they present this type of fining upward sequence, and this feature is found to be preserved in the sedimented beds. If the fining upward sequence is found to point downwards as in this figure, so it is a clear case of overturning of beds. Similarly, shoal markings in muddy beach basins are found to be preserved by subsequent sedimentation process. If it is a shell layer and the organism has moved over it, so the footprints are there in the shell or the muddy beach. So these shoal markings are the depressions whose shape is the shape of the footprint of the concerned organism that has moved over it. Subsequently, if these depressions representing the footprints are found to be filled up by later sedimentation, say sand fills these depressions and are found to be preserved, then sedimentation took place. So the very shape of these depressions, indicating the shape of the footprint of an organism, cannot be project upwards. If in any place it is found in this manner in a bed, these shoal markings are there, but they are pointing in opposite direction. That means this is not the original process of their formation. That means it is case of overturning of the concerned bed. So the shoal markings are also useful in determination of top and bottom of beds. Similarly, rain prints are also useful. If they are found to be preserved, they are useful in determining top and bottom of beds. Next, we will see that local nonconformities are also useful in determination of top and bottom of beds. When the rivers are in spate or are in flood, new channels are being created along the path of the river course. Subsequently, no water flows in the channel and it remains as a basin, and it gets filled up by coarse grained fragments, say it gives rise to conglomerate. And again they are found to be sedimented by fine shell materials. So this is shell, and here it is a basin that was created because of sudden flood. Subsequently it was sedimented, it was filled up by conglomerate, and it is overlain by again finer sediments like that of shell. So this is a basin shape, and basin contains the coarse grained fragments. If in any area we find a basin shape is like this, containing coarse grains, we can never expect such a accumulation in a unstable condition. This looks totally unstable. We can never expect a basin is pointing upward and it is containing the coarser rock fragments or boulder components in this manner. So this type of feature, if it is traced in field, it will indicate that the strata here are overturned. So local unconfirmed, because this basin was created, remained as a site of non-deposition for certain time, and again subsequently it gets deposited. That's why it forms a local unconformity. So local unconformities are useful in determination of top and bottoms, provided the basin is found to face in this manner. So this is a case of overturn. This is right side up condition. This is overturning of bed as established from this channel, erosional channel, or local unconformity. Similarly, related features showing fragments of lower shell bed in above deposited sandstone and also fragments of pillow basalt lava flows contained in overlying sedimentary bed are indicative of top and bottom beds, as evident from the following diagram. Let us say this is the pillow lava. It will be eroded, these components will be released, this will be here. If it will be eroded, this component will be released, it will be here. So let us say it is a shell layer. So shell layer contains these fragments which have been derived from the bottom lava flow. So this is a normal process of finding the fragments of lower bed in the upper bed. But if you see that these fragments are occurring at the bottom, as it is here, and here it is the igneous body, and its components are here in the lower bed, which can normally never be possible in any sequence of sedimentation process. So here it is a clear case of overturning of beds. The fragments of lower bed found in upper bed in the normal condition, but if this feature is found to be in reverse condition, then that will indicate the overturning of beds. So by observing these features, these local unconformities or the fragments of lower bed in the upper bed, it is possible to establish whether the strata are in right side up condition or are in overturned condition. Then let us see drag force. How drag force are useful in determination of top and bottom of beds. Drag force result due to shearing of two competent beds covering an incompetent bed. So in the middle we have the incompetent bed, on the top and bottom we have the competent beds. These two competent beds, they are found to shear past each other. If it is in this manner, so it will be this type of fold which develops in the incompetent bed because of shearing past of the upper bed and lower bed. And the shape of the drag fold comes like this. And this drag fold is useful in deducing the major structures. How? In order to know it, we have to remember the fact that the upper beds move away from the synclinal axis relative to the lower bed. This is the fact. And the incompetent bed in which the drag folds are found, their axial planes make certain angle with the overlying bed or the underlying bed, and the fact is that the acute angle between the bed this is the acute angle. Acute angle between the axial plane of the drag fold and the bedding that always points along the direction of differential movement. This fact we have to remember. And the beds always move away from the synclinal axis, that we have to remember. If we remember these two facts, then it will be useful to deduce the major structure and say whether the strata are in upside, whether the strata are in right side up condition or are overturned. So let us see. So here, this is the incompetent bed. It is containing these drag folds. So we have to draw the axial planes of these drag folds. So this angle that we see between the bed and the axial plane, this is the acute angle. If this is the acute angle, then along the acute angle direction, the bed has slided. Similarly, on this side, this is slided like this. So this is sliding. Here, this is the sliding direction. So I have already discussed that the beds always slide away from the synclinal axis. So here the beds slide away. So it must be a syncline. If it is syncline, it will be bordered by anticlines. So this will be anticline, this will be anticline. So this is anticline. And in the anticlines, we have to see how are the limbs. So we, by using the drag force, we could establish that this is syncline. So here will be anticline, and then we will look at the limbs, whether the limbs are in right side up condition or are overturned. Let us see this diagram. We have found three places where the drag folds are available, and the clear picture of the fold is not traceable. But by taking into account this angular relationship between the axial plane of the drag folds and the bedding and the acute angle, we see that the movement is like this on this side, the movement is like this on this side. So the beds are moving away from each other. That's why here is incline, which is not possible to say from the edge data. But if we take into account the attitude data of drag force, it is proved that this incline is here. Then on this side it will be anticline. And if we join the structure, we see that this limb is found to be overturned, because if the anticline would have been in this condition, it is normal. But now we see that anticline the limb has been turned like this. But this limb and this limb, they dip in same direction. That means this limb, a part of this anticline, is showing overturning character. Thus, by use of drag force, we can deduce the major structure. The fact is that we have to establish the synclinal axis, then syncline, then anticline, and then we will look at the limbs, whether they have been in right side up condition or are totally overturned. So this is the way how we establish how the bedding or the drag fold and bedding relationship can reduce the major structure. At B, the acute angle between axial plane and the drag fold bedding is showing that the syncline is to the left at B. So syncline is here. This side indicate syncline. So anticline must be on its both sides. Therefore, we join these beds and reduce the structure like this. So here it has been overturned. Here it has, at C it has been overturned. So in this manner, we will be able to use this drag force to reduce the major structure. Similarly, we have another feature, that is the pillow structure, the pillow lavage. They are also useful in determination of top and bottom of beds. So how pillow lavage is useful in determination of top and bottom, that we will discuss. Pillows are convex upwards and convex downward. These are the pillows. When the volcanism takes place in the marine condition, pillow-like bodies are being produced from lava. Particularly albitic lava provides these pillows, which are doubly convex bodies. But the top portions of the pillow lavage present the vesicles or the cavities that represent the place where there is accumulation of gases at the time of cooling and consolidation of lava. And these vesicles, these gas cavities, are always found to be located on the top side of pillows, not at the bottom side. So this is convex and contains the cavities. So if any rock horizon, we see that the cavities are pointing to the bottom, that rock body can never be expected in right side up condition. It is a case of overturning of beds. So in this manner, the pillow lavage, they are also useful in determination of top and bottom of beds. So these are some of the factors, or these are some of the points, methods by which it is possible to identify whether the strata are in right side up condition or are totally overturned. And these features are studied in order to detect the history of the area that presents the sedimentary features, whether the entire area has been deformed or the strata are overturned, as we see normally in the folded terrains, in fold mountain belts, where severe compressional forces come into picture, in which the strata are being crumpled and upheaved and may be overturned. Thus, these features that we discussed are studied in the sedimentary horizons and are correlated and are inferred to establish the major structure with which they were associated, and thus the process of determination of top and bottom of beds could be possible by use of these sedimentary features, deep and strike data, ripple marks, current bedding, dead bedding, soil markings, willow structures, dark folds. All these features they are taken use of to determine top and bottom of beds. Thank you.